Yes, ma'am. Yes, ma'am. கேக்குது ma'am. பசங்க guys, are you able to hear the ma'am voice? Hello? Guys, ma'am ஓட வாய்ஸ் கேக்குதா?
No sir.
கேக்கலையா?
மேம் வாய்ஸ் கேட்கல சார், உங்க வாய்ஸ் கேக்குது.
ஓகே.
இப்போ கேக்குதாமா?
ரொம்ப லோவா கேக்குது சார்.
ரொம்ப லோவா கேக்குதா?
வித்யா மேம்.
சார்.
ஃபர்ஸ்ட் டெஸ்க்ல வச்சிருங்க மேடம்.
சார்.
ஃபர்ஸ்ட் டெஸ்க்ல வச்சிருங்க மேடம்.
டெஸ்க்லயா சார்?
ஆமா.
டெஸ்க்ல வச்சா எப்படி சார் கேக்கும்?
இல்ல இப்ப நல்லா தான் கேக்குது. இப்ப கேட்டு பாருங்க பசங்க.
வாய்ஸ் கேக்குதா மறுபடியும் கிளியரா?
எஸ் மேம்.
ஓகே. போனிங்க வச்சிரேன்.
வித்யா மேம். வித்யா மேம். வித்யா மேம். மேம் நீங்க கையில வச்சுக்கோங்க மேம்.
கையில வச்சுக்கிறதா? ஓகே.
எஸ் மேம்.
So I'm going to the module 2.
இருங்க மேம், பையன் நீ ரொம்ப கம்மியா தான் வந்திருக்காங்க.
Yes sir.
நீ டைம் ஆகல மேம்.
Okay sir, okay sir. Have you all joined the Google Classroom?
Guys, only nearly 70 students are joined in the Google Classroom. Remaining, what about the remaining students? What is the problem to joining in the Google Classroom? Any issues you are facing? We are asking in the group, but you are not updated there. So what is the problem to joining in the Google Classroom? Is there is any problem? Only 34 and 35. Totally, nearly 68 students were only joined for the group. What about the remaining students?
And then
we have uploaded
module 1 part A, part B question with answers. So please check it out.
Yeah, our part is over for the module 1. Module 1 we have uploaded questions, both questions and answers, and also the question bank also we have uploaded, and then module 1 notes also uploaded, PPDs are uploaded, so and videos, our class video lectures are uploaded. So regarding module 1 we have finished all the things, but from your side some not many, nearly only 60 were responded for. If you are giving a MCQ questions on that, only 60 to 65 people are only responded. What about the remaining people? So keep it in mind. If you submit the question whatever we are giving in the class and we are going to discuss in the class and MCQs like that, we only give the internal marks. So keep it in mind, and that you want to submit all the things. Okay, so if you are giving time by today, you want to submit means you want to submit by today, so not make more time. Nearly we have given 4 MCQs, and today we are going to give one assignment also, but the submission level of the students is only nearly 60 or 65 students only submitting regularly. Remaining students, if you are not submitting means We will not give any mark to you. Okay, keep it in mind, and then you proceed further. So today we are going to start our second module. Ma'am, only 34 are joined, ma'am. We will wait for a while, ma'am. So, what about the module 1? If you are having any doubts or any difficulties in module 1, anybody unmute and answer the question. If you are having any difficulties in the module 1, did you see anybody see the notes which we have shared in the group? Anybody see? Anybody visited the Google Classroom? The material we have shared? 109 Google. Did you see the? Did you join in the Google Classroom first? 109 Google.
சார் கேக்குது சார்
ஜாயின்
Hello, sir.
பண்ணிட்டீங்களா?
எஸ்
கூகுள்
சார்
கிளாஸ் ரூம் ஜாயின் பண்ணிட்டீங்க?
எஸ் சார்
பாத்தீங்களா மெட்டீரியல்ஸ் எல்லாம் பாத்தீங்களா?
எஸ் சார்
நீங்க எல்லாம் மெட்டீரியல் எழுதி வச்சிருக்கீங்களா? இருக்கா உங்ககிட்ட?
இருக்கு சார்
மாடியூல் 1 எப்படி இருக்கு? ஈஸியா இருக்கா?
இருக்கு சார்
பாருங்க சரிங்களா? சம் நமக்கு நம்ம
சார்
மியூட் பண்ணிக்கங்க.
ஓகே சார் ஓகே சார்
சம் நம்ம சால்வ் பண்ணிருக்க சம்லயே மாடல்லயே தான் வந்துட்டு மிச்ச சம்ஸ் எல்லாம் இருக்கும். What we are solved in the class, the same thing is going to there in your module 1. Number only changes. Okay, so we are given answer for that also. So kindly make note it and try to study it. Okay, Vidya ma'am, 50 are joined now. 50 students are joined now.
So let's start. Others may
Yes ma'am, we will start. We will start then. Let us. They will join.
Second module is drive motor characteristics. Is board is visible to all of you?
Yes ma'am, visible.
Yes. So the second one, the drive motor characteristics. Already said in electrical drive motor. In this module, I'm going to talk about functions and characteristics, and then how it will be started and how it will be started.
Vidya ma'am.
Yes, sir.
Vidya ma'am.
Yes, sir.
If you கீழே போச்சுன்னா சவுண்ட் கம்மியா கேக்குது மேம்.
Okay, sir. Okay. So in second module, I'm going to talk about the starting and braking, and then characteristics of the motor. So before that, already I have explained in the lab session what are the classification of motor. The motor is mainly classified into DC motor and then AC motor. Today I'm going to talk about only the DC motor. What are the types and how it will be varying according to the torque and speed. I'm going to derive the torque equation and the voltage equation and the EMF equation. I'm going to talk about only the DC motor. Maybe in our next class I have discussed about the AC motor. Before that, what is meant by motor? What is meant by motor?
Anybody tell what is meant by motor? 220 Praveen Chandru. Can you explain what is meant by motor? Praveen Chandru.
Hello, sir.
What is meant by motor? Please answer
Hello,
the
sir.
ma'am.
What is meant by motor?
Please answer the question.
சார் ஒரு மிஷினை ஓட வைக்கிறது இப்போ தான் சார் மோட்டார். மிஷினை ரன் பண்றதுக்கு மேம் கேட்கணும் மேம்.
கரெக்டா?
What is the function of motor? Is it the you are saying something machine move
Shaft by magnetic field.
I'm asking the definition or the function of motor. What exactly it does?
மேம் கேட்கும் எக்கோ அடிக்குது.
Yeah, Parthasarathi, it's correct. Converts electrical energy into a mechanical energy.
Yes, it's nothing but it converts electrical energy into mechanical energy. That is called DC motor. A DC motor, again the construction wise, you have to go with the field winding and then armature winding. This is what I thought in the Tuesday afternoon lab session. What is my field winding and armature winding? Just go through your notes. I have talked about the field winding and armature winding in the Tuesday class itself, and then I have explained how the motor will works. And all, have you all remember that? Have you all? Yes, what is meant by field winding? And then armature winding.
What is field winding and armature winding?
This is what, if I said what is meant by field winding and armature winding, I think this is the fourth time I am saying about the field and armature, because in the introduction class I have talked about the construction the same way the last lab class I have told about the field winding and armature winding, and again now I am going to talk about the same concept, field winding and armature winding.
Anybody?
Have you all know or not?
What is meant by field winding and armature winding?
Listen, read that question. I will explain again the construction of DC motor once again. Interaction of two fluxes, the torque will be produced because the output of the motor is torque. Not to get the torque, we need two fluxes. So the two fluxes, the first one is main flux, and then second one is armature flux. Yes, sir.
They're telling that the voice is not clear. I'm able to clear. Guys, anybody unmute and tell what is the problem with it?
Keep my mobile near my mouth only, sir. It's nearly close to you.
It's audible to me, but they are telling that it is not audible.
It's
Guys, what is the problem?
Sir, voice up and low ಆಯ್ತು sir. ಕೇಕ್ ಮಾಡಿ.
Okay, I'm increasing my field winding. Is it clear? Field winding. My voice is audible now.
Yes, ma'am.
Yes, ma'am.
The main part of the motor is field winding, armature winding, because we need the output of motor is torque. Torque I have get by the interaction of two fluxes. So the first flux is main flux. I'm getting the main flux in order of the field winding. The same way the armature flux, with the help of the armature winding, I'm getting. So interaction of the two fluxes, I'm getting the torque. So that's why it's a major part of the DC motor. Already said, I have talked about the pole shoe, armature winding, field winding, and then commutator and brush. The same I'm going to discuss about the construction wise, because then you can know how the EMF and then torque will be getting the construction wise. So the main thing is pole, because the pole play a vital role, because then depends upon the pole, the speed will be varying and then output also varying. This is my pole. So totally I have connected 4 pole. This is the field winding. I have connected the copper wire here. This is my field winding. This is my pole, and then this is my field winding, and then this is my pole shoe. In order to strengthening or increasing my flux, the pole shoe will be always in the enlarged size. And the next one, moving with the armature part. This is my central part of the motor. This is called armature. This is called armature slats. There I have placed the armature winding. Is my voice is audible now? Is it clear? Somebody unmute and say, is my voice is audible?
Yes, ma'am. Yes, ma'am. I will, ma'am.
Okay, okay. All the poles have carried a field winding. Again, the outer layer part is called yoke. And then it is connected. This is the construction of DC motor. The outer layer is yoke. Yoke is nothing but to protect from the environmental conditions aspects. I have connected the outer layer. And then the next one is pole shoe, and then armature winding. This is my armature winding. The whole setup, I used to say armature. And then this part is field, and then this is my commutator. And then the last one, brush. This is the construction part of DC motor. I'm repeating once again. If I'm giving supply to both field and armature, there is the flux will be producing whenever a current carrying conductor or if I found a coil in any iron path, it will act as an electromagnet. So there is a imaginary magnet will occur. The imaginary lines are you used to say is a flux. So whenever I'm giving supply to a coil or a wire wounded coil, there is some flux will be produced. So here the flux will be produced because the field flux or main flux. The same way, armature also gets supplied from outside. So the armature winding will produce the armature flux. Okay. Here the main flux will move to the armature while the pole shoe will be enlarging, so the main flux will be strengthening due to the construction, the enlarged part of the pole shoe. Again, it will be traveled to the armature. There the armature flex and the main flex will be interacted. So there is a EMF will be produced. Due to the EMF, the torque will be produced because what is that? Everything we need some force. Without EMF, I cannot produce torque and flux. So EMF as well as torque will be produced. The torque, which is nothing but anything, two interaction of two fluxes are always AC in nature, but I need DC motor. So I have to connect with commutator. Here the torque will be, the AC torque will be converted into DC, and then finally my output torque or the rotation will be carried out with help of the brush. This is the construction part of the DC motor. You all got my point? Have you all? Have you all any doubt? Shall I repeat once again?
Repeat once again, ma'am.
Okay. Again, repeating the construction why DC motor and DC generator are same. If it is a generator, you have to rotate the armature because armature input is mechanical energy and then output is electrical energy. But here, it is the input is electrical energy, so I am giving supply to both field and armature. So whenever I am giving supply to the winding or wire wound coil, there is flux will be produced. So here flux will be produced, that is called field flux or main flux. Again, the armature also will have produced one flux is armature flux. And then main flux will move to the armature. There, the interaction of flux will be occur in the armature winding. So the torque will be produced. I already said the interaction of the two fluxes will produce the torque. So normally, the interaction of two fluxes will produce AC in nature. In order to convert DC, I have connected with the commutator. The commutator is converting my AC torque into DC torque, and then finally the output will be carried out by the via That is the function and then construction wise the DC motor. Here the output will be taken via the interaction of two fluxes. There, while the interaction while there is some force will be occurring, then only we can get the torque. So without a force, we cannot get the torque. So there is some movement will occur in the armature part. Yes. You all understood or not?
Guys, please mark
I
chat.
have repeated one again. Have said once again too. Have you all understood now? Somebody unmute and say,
Yes, ma'am.
have you all know the
Yes, ma'am.
construction and then how it works the DC motor?
Yes, ma'am.
Yes, have you all? So now you all know about the field winding and armature winding and all.
Ma'am, they have posted in chat box as yes, ma'am.
Yes, okay. So DC motor, the main parts are the field winding as well as armature winding. So the next one, I'm going to talk about the EMF and then torque equation and then voltage equation of the DC motor. The construction wise, I can say how I'm going to track the EMF. Here in motor, I used to say is that EMF is back EMF. E is nothing but EMF. I used to say is back EMF. Y means I will say before that how the equation will be and Z 68. My back EMF equation. I is nothing but it's flux. Please note it down. E is nothing but flux and T is nothing but number of poles. M is nothing but speed. And then Z is nothing but armature conductor. And then A is nothing but parallel torque. I will say how I am deriving the equation and all. Before that, I have copied the back EMF. I'm going to say why it's called back EMF and then how I'm going to derive the equation and all. If you copy it, let me know. Then only I will say why it is called back EMF.
Ma'am, Vidya, ma'am,
Yes, sir.
please it is not clear that equation. Erase it and use left side now.
Was it clear now?
Now it's okay.
I is flux,
Yes, ma'am.
P is pole, number of poles, and then N is nothing but speed, And Z is nothing but armature conductor. And then A is nothing but parallel path. See why it is called back EMF. According to the Lenz law, here the EMF will be occurred in the interaction of the two fluxes. There EMF will be produced. It always opposes the supply producing it, which means I will say in Tamil. அப்பதான் உங்களுக்கு புரியும் நினைக்கிறேன். EMF எப்படி அப்படின்னா எப்படி உருவாகும் அப்படின்னா ஆர்மேச்சர் நான் சொன்ன மாதிரி ஃபீல்டு ஃப்ளக்ஸும் ஆர்மேச்சர் ஃப்ளக்ஸும் ஆர்மேச்சர் பேட்ல வந்து ரெண்டு இன்ட்ராக்ட் ஆகும்போது டார்க் ப்ரொடியூஸ் ஆகும். அப்ப ரெண்டு இன்ட்ராக்ட் ஆகும்போது there is some force will be produced. That force is called EMF. But here I used to say is back EMF because அப்படின்னா எதனால அந்த ரெண்டு ஃப்ளக்ஸ்னால ஒரு EMF இன்டியூஸ் ஆச்சு, எந்த ஃப்ளக்ஸ்னால அது இன்டியூஸ் ஆச்சோ அதே ஃப்ளக்ஸை இட் வில் பி அப்போசிங், அதுவே அப்போஸ் பண்ணும். அதுதான் லென்ஸ் லா. ஸோ அப்ப என்ன ஆகும் அப்படின்னா it will be opposing the cost producing it. So it always less than the supply voltage. So in normally the motor EMF I used to say is a back EMF because it always less than the supply voltage. And then it will be always oppose the cost producing of it. So which means it always about opposing means the EMF will be very less. Yes or no? So that's why it is called a back EMF. Again, it will be deriving. I'm going with the construction wise. The first one, what is pole here? How many poles are there in the construction? See and tell how many poles.
4.
Buddy, unmute and say how many poles are there?
4.
Yes.
4.
4, ma'am.
Yes, 4. And then what is pi? Flux. Flux is nothing but here I am giving supply, that is the flux will be produced. Are you agree that? So it will play a vital role in the interaction of the EMF or flux. So interaction of the flux, the EMF will be produced. So the EMF will be depends on the flux and the number of pole. So first one is over. It will be flux and then number of pole. The second one, again, it will be come under the speed because it will be what will happen? The interaction of the two fluxes will be produced. So it will be torque will be interact here. So the torque, while whatever happened, the torque, another name is called rotating force. So there is some rotation will occur. You have to consider the speed also. And then that armature conductor, I already said I have connected the number of slots is nothing but armature conductors. Here I have placed the armature winding. So again, the maximum how many armature conductors is there, again it will be affect on the back EMF also. So again I have to go with the armature conductors. And then finally every time I have to say in the one revolution or per 1 minute, so I have to divide by 60. And then A is parallel path. Parallel path is nothing but I have connected the winding with respect to lap or wave winding. Here again, while coming to the armature conductors, I have connected the so many number of winding into the armature conductor. So it will be I have connected with the lap winding and wave winding. Is it clear here? So
Ma'am. Left side, ma'am.
And wave winding.
Ma'am, use left side, ma'am.
Use left side. Here I have right here. It is lap winding and then wave winding. There's nothing but if I'm connected the winding with respect to this is my lap winding. There is no interaction of the winding. It will be followed the same way. If it is wave winding, there is some overlap will occur. This is my wave winding. So if I'm connecting with respect to lap winding, my parallel path will be A is equal to P. If I'm connecting the winding with respect to wave winding, it will be 2. Always you have to use while solving this problem. I'm repeating once again how I'm getting this back EMF means by the construction part only. Again, I'm repeating. First thing, you have to, again, I'm repeating the number of poles. So, depends upon the number of poles, it will be, the back EMF will be varying. If the pole will be very less, again, the flux will be very less. So, in order to that, I have connected this so many number of poles. So, it will be affect on the creation of the EMF. So, we have to take first the number of poles, pi, and then, n, and then pi. Pi means flux. Flux, if I am giving supply, there is some flux produced. So, the depends upon the flux only, the EMF will be produced. So, we have to consider the number of poles as well as the flux. The next one, the speed, because it will be started rotating, because the interaction of the two fluxes, the torque will be produced here. So, it will be done some speed. You have to take the speed also. Again, I'm coming to the armature part. You have connected so many armature conductors there. You have to take the armature conductor numbers also. And then that's why I have connected Z. So Z is nothing but armature conductor. And then 60, every time you have to say in the 1 revolution. So 1 revolution is 60 seconds. I have divided by the 60. And then A is nothing but parallel path. If I am connecting my armature winding is lap, it will be connected with it is like that. And then if it is wave winding, it will be overlap with one winding to another winding. So coming to that, the parallel path will be varying. If it is lap winding, my parallel path always A is equal to P. P is nothing but number of pole. And then A is equal to 2 if it is wave winding. Is it clear? Have you all seen what is meant by lap winding and wave winding and all? Is the diagram is visible or not? Is it visible? Or shall I erase and then I have to draw the center part?
Guys, the diagram of lap winding and wave winding is visible.
Have you all cleared what is meant by lap winding and wave winding, first of all?
It's important. We are having some problem
Very
also.
important while solving a problem. It is very important. They have given in the problem a 4-pole, a 3-phase winding or 4-pole, 1500 RPM winding, this lap connector. There you can use A is equal to P. P is nothing but number of pole.
If you're having any doubt or any issue, please revert back. This diagram is clear or not?
Is it clear or not? As shall I erase and then I have to redraw in center part?
Clear, ma'am.
Okay. Is it clear? If it is lap winding, I'm repeating once again, in armature conductors, I have placed the armature winding. The armature winding, they have connected the two types, the way of connection. It is made that maybe lap winding or wave winding. Lap winding is nothing but, it will be, the lap winding is parallel path. It will always follow by like this. They won't touch each other. But here, in wave winding, the one winding is overlapped with another. It's look like a wave. So if it is lap winding, so my A is equal to P. P is nothing but number of pole. So where you have substituted here, if it is lap winding, here you have to multiply with P also. So the P will be cancelled if it is lap winding. I'm repeating once again. If my question is lap winding, so my A is equal to P. I have substitute instead of A is equal to P. So what will happen? I can eliminate PP. So the equation will be pi n z by 60. Because number of poles is same. So here on P, it will be cancelled. So pi n z by 60 for lap winding. If it is wave winding, you have to multiply with 2 because A is equal to 2. So 60 into 2, the P will become like this. This is the equation for lap winding as well as wave winding. If I'm going in deep with lap winding, it is a decision part of the machine that is not needed in your syllabus. That is not needed to your mechanical. So I'm teaching what is lap winding and what is wave winding and all. Just you should know how the construction wise, if it is connected in parallel with it is followed by one winding to another winding, it is called lap winding. If one is overlapped with another, it is called wave winding. So depends upon the lap winding and wave winding, my parallel path will be varying. If it is lap winding, A is equal to P. If it is wave winding, A is equal to 2. So if I'm going to substitute the value here, if it is lap winding, A is equal to P, the P will be get cancelled. So the equation will be lap winding is nothing but pi n z by 60. If it is wave winding, the equation will be 60 into 2 because A is equal to 2. So it will be pi p n z by 120. This is the basic equation of the motor. Is it clear or not? Is it clear?
Anybody have doubt in this? Wave winding
Have you all
AC.
copied the equation? Do not mug up the equation. You have know that the construction wise, you can write from the here. Here the number of volt will come, and then flux, and then speed, and then armature conductor, and finally the way of connected the winding. So 60 by A. So from this you can easily write the EMF, the back EMF equation of the motor. See why it is called back EMF? It always opposes the supply producing it. So that is called back EMF. So the back EMF always less than the supply voltage, but in generator it is not like that. Back EMF is EMF will be very high because the output of the generator is EMF. In case of motor, they have set the back EMF. Have you any doubt in it? Any doubt? Please ask now itself, then only I can go with the next topic. If you don't know about the back EMF and then equation, then there is no use of going to the next equation. Is it clear? Somebody unmute and say, is it clear or not?
Is anybody having any doubt regarding the basic equation on the DC motor parts? Guys, unmute and answer.
I'm talking with you only. Is it clear or not?
Clear, ma'am.
Clear. There is no doubt in the back EMF and then the construction wise. Yes. And then next I'm moving with the voltage equation of the DC motor and then torque equation of the DC motor. If I'm completing the torque and voltage equation, then only I can move with the construction, the types of DC motor. Yes. And then the construction, the part will be same in the board. I won't erase this because from this only I'm going to talk about the types of DC motor. So I'm going to erase the another things. Please copy the lap winding and wave winding and then the equation. Please note it all. So I'm erasing from first. The next one is voltage equation of DC motor. I'm writing in the short form. Don't write like this. You have to write voltage equation of motor. Please write the full form. voltage equation of DC motor. Yes. What is EB? What is EB? What is EB?
332 Vice Prasad. Please answer the map's
What
question.
is EB?
What is CB? 332. 332. Unmute and answer the map's question. What is EB? If you are not
Make
answering
him
the
as absent,
question,
sir. Make him as
if you not answer the question, you will be marked as absent. Okay, 332 absent. Okay, 331. Can you answer the question? What is EB? It is a basic question only, which we have taught
Back
earlier.
EMF, sir.
Yes. What is
Back
EB?
Back EMF.
Yes. Before only I said what is back EMF, and then have talked about the derivation and then equation of the back EMF. I already said back EMF is always less than the supply voltage. That's why they have write it as V is equal to EB plus IA into RA. So here back EMF, the back EMF formula is pi P N Z by 60A, and then IA is nothing but armature current. Please note it down. Armature current. RA is nothing but armature resistance. See why I am moving with this armature part? Because they have the two parts, field as well as armature. But in all the cases, in motor as well as AC motor or DC motor or AC generator or DC generator, we have only take with the armature values only. Why? Do you know any cases? Any guesses? Why I didn't take the field winding and then field armature? Because I already said this is the armature and field windings play a vital role, because there only the flux will be produced. After that, in armature only the interaction of the two fluxes will be occur. So why I am taking the IA and RA? Why I should not take field IF and RF? Please note it down. If I have entered the F here, it is means it's a field current. Please note it down. And then if it is A, is nothing but armature. You have to follow up to module 3. Here, A is armature, F is nothing but field current. It is field, it is armature. So I have ended with the F and then A. So every time I have to write A means you have to go with armature, and then F is field. See why I am moving with the armature part means there it's play a vital role, because here only the starting current and then torque will be produced. In order to control the starting current and starting torque, you have to do something in the armature part only, because there only the interaction of two fluxes will occur here. So this is play a vital role instead of field. So that's why I have took the armature current and then armature resistance value. Everything is in all the motors, the field winding or field resistance as well as armature resistance as there. So I have to write IA into RA. See why armature? Have you all got my point? Why I have took the armature value instead of field? Why I didn't took field winding and all? Yes, because everything occur in the armature. The interaction of the two fluxes, and then here only the torque will be producing. So instead of adjusting the field, I could adjust the armature. If I'm adjusting the armature, I can control the what is that output torque and then speed also. So that's why every time they have took the armature value first. We have give the preference to the armature only. Then next I'm going to the starter. There you can know the importance of the armature. Okay, I can control the starting current and starting torque with the help of the armature only. So I have took the armature values only. So that's why I have took V is equal to EB plus IA into RA. IA is nothing but armature current. RA is nothing but armature resistance. This is the voltage equation of my DC motor. I'm talking about only the DC motor. I didn't go with the AC motor. AC motor is different. Any doubt in voltage equation? Any doubt? Yes? Any doubt? Any doubt?
No, ma'am.
No. And then next I'm moving to the types of DC motor. Have you all copied the voltage equation? Have you all?
The amount dark equation.
Yes, sir. Sorry, sir. Torque equation. The next one, torque equation of DC motor. Because the output of the DC motor is torque, so is the output equation of DC motor. Torque is nothing but rotating force. The output is mechanical energy. So I'm going to derive the torque equation of the DC motor. The first, so once I finished, I will tell the equations. The first one, half took for one revolution. So it will be, I have took the one cycle. So it will be done. The second by force, because the rotating force, I used to take the torque, this is the radius.
Ma'am, voice not clear, ma'am.
I have kept. Work done is equal to F into 2 pi R, because the 2 pi R is nothing but the area of the circle, because everything will be run in the circular wise only. So I have to work done with respect to F into 2 pi R. F is nothing but force, and then 2 pi R is nothing but area of circle. So the next one, normally the power developed, which is equal to work done by time. This is my work done. So I have substituted the value F into 2 pi R. Time I have to took for one revolution. So 60 by N, because I have to took the speed also. So 60 by N. So I can rearrange So F into R, the N will become to the upper side. So it will be 2 pi N by 60. We know that angular velocity, omega, is nothing but angular velocity. So 2 pi N by 60, I can rearrange the 2 pi N 60 instead of omega, and then F into R, I can write it as T dot. R is nothing but radius, and then F is nothing but force. So this is the power developed by motor or 1 revolution of the second. So it's T into omega. Once you copy it and say, then only I can continue the next step also. This is the first step. From this only I can derive the torque equation. Or shall I erase this? Better I am erasing the construction and then only you can understand. This is my final equation. I'm repeating from starting. So I have to take the 1 revolution. So I have to be 1 revolution.
Yeah, ma'am. Yeah, ma'am.
Sorry, work done. I have to took the 1 revolution with respect to radius and force because I'm going to derive the equation for torque. So torque is nothing but rotating force. So this is the basic. The work done is nothing but force which applying for the circular circle or circular. So what is that? F into the area of the circle is 2 pi r. So next one, the power is equal to the normally the power developed, which is equal to work done by time. How we are going to work? The particular time only I can say the how much power I have applied. So work done by time. So work done value is nothing but F into 2 pi r. The time I have to took for 1 revolution. So 60 revolution means you have to take the speed also 60 by n. So after that I can rearrange the 60 by n. So it will be F into r. We know that 2 pi n by 60 is omega. So I can rearrange the equation. P is equal to T into omega. This part I can write it as omega is nothing but angular velocity. And then this is F into R is nothing but torque. After that, I need a power developed. I'm going to find out the armature torque. So because the output of the torque, I can apply from, I can get the from the armature. So I can derive the armature torque with the help of the problem. So power in the armature, which is equal to armature torque into omega. So every time you have to say in the angular velocity, how it will be occurred, how it will be in for the 1 revolution. So have took for the angular velocity. We know that power is equal to V into I. So instead of I can write it as IA because it's armature. So you have to took the armature current. And then V is nothing but voltage. You can write it as V is equal to E also. So I can write it as back EMF because it is DC motor. You have to write it as EB. After that, armature torque is nothing but PA and omega is nothing but 2 pi n by 60. The same, I can follow the P is equal to T into omega. The same formula I'm going to apply for power. I can substitute EB into IA and then armature torque, because the output is from armature, so I can write it as TA, and then omega is equal to 2 pi n 60. நீங்க என்ன யூஸ் பண்ணனும் அதே தான் இங்க வேர்ட்ஸ்ல எழுதி இருக்கேன். So again we know that formula EB value, so pi p and z by 60A. I'm going to substitute the value here, and then IA and then TA into 2 pi n 60 here. 60 is common. I'm going to omit the 60, and then n will be cancelled because it is same. From this I can write as TA is equal to, it will be come into the division side, so 1 by 2 pi IA PZ by A. This is the armature torque, the final output torque of my equation. Here, from this I can write it as my torque is equal to, here 2 pi is constant or variable. Anybody? Have you all understood the torque equation first? Then I will say how I'm going to solve the next one. Have you all understood first of all what is in my torque equation? How I'm going to derive, how I derived the equation and all? Have you all understood?
Guys, anybody having doubts?
Are you okay or not?
Are you able to follow the?
Are you able to follow?
Okay, ma'am.
Okay, wow. Okay. Then now somebody unmute and say which are the constant value or which are the variable value. So 2 pi is constant or variable? Somebody? 2 pi is constant or variable?
Constant, ma'am.
Constant. So why the next step is the torque is directly proportional to, because if it is variable then only my torque will be variable. If it is constant, there is no variation in the torque. So I'm going to derive the next equation. So 2 pi is constant, so there is no effect on my torque. Yes, are you agree that? Are you all able to follow my the derivation part? Have you all follow my the words? Have you all able to follow? Here, there is some constant parts is there. If it is the value is constant, there is no variation in the torque. So, yes or no, are you agree that? If it is the 2 pi is constant, there is no variation in the torque. So, I can omit that. P, number of pole is constant. You cannot vary it. So, P is constant. Armature conductors, we cannot vary it. So, it is also constant. A, parallel path, it is also constant. So the torque is directly proportional to only the pi into IA. This is the main equation. From this only I can talk about the characteristics of the motors. So this is the main important equation. This is the very, very important. See how I am getting this equation. I'm repeating once again. Have you all clear about the torque equation first of all? Have you all? I simply have took the one revolution. For one revolution, have took for the work done. From this, I can find out the power developed. Power is nothing but work done by time. This is how you have studied in the 12th standard itself. There you can study the power. Power is nothing but work done by time. The same formula I have used here also. The work done is nothing but here I have took for the one circle. Here the work done is nothing but force into area. So F into 2 pi R. I'm going to substitute here. So F into 2 pi R. Time, every time you have to took for one revolution. If it is one revolution, you have to multiply by 60. And then you have to took for the speed value also. So 60 by 10 N. So what's up? So time is equal to 60 by N. After that, I'm going to replace. So the N will be coming to the upper side. So it will be F into R. We know that 2 pi N by 60. That is the common formula, omega angular velocity. So it will be 2 pi N by 60. So I can rearrange the equation with respect to omega and then F into R. The rotating force, that is called torque. So I can write it as RT. So P is equal to T into omega. The same formula I have write it as in terms of the armature. So power in the armature is nothing but PA. Then TA. So PA is equal to TA into omega, the same formula. So we know that omega is equal to 2 pi n by 60. Power, I can write it as voltage into current. I in terms of IA, because I have talking about the armature. So IA, the same way, I can write it as E also. You have to, while coming to the DC motor, you have to write E with respect to EB because it is back EMF. So EB into IA. So we know that EB value, EB is nothing but pi P N Z by 60A. I have substituted the value here. IA will come this and then TA into 2 pi n by 60. Here 60 is common. So it will be, I have cancel the 60 and then n common. I have take it as cancel and then from this I can write it as TA is equal to 1 divided by 2 pi IA P Z by A. Here the next step, my number of poles and armature conductors and A and then 2 pi will be constant. If my machine working or not, it won't affect. So the number of poles and Z and then A will be always constant. The constant value will not be changed the armature torque. So the flux and IA will be varying because every time if I'm giving supply, if I'm giving less speed or 1 by 4th of the load, my current will be varying. If my current will be varying, there is some always change in the flux. Current change ஆச்சுனா கண்டிப்பா flux change ஆகும் because current இருந்தா flux கிடைக்கும். So what will happen if I'm changing the load or changing the speed? There is no effect on number of poles and armature conductors and A and then 2 pi. It is constant value. So you won't take this value. So that the torque is directly proportional to the pi into IA because armature current will be varying and then if my current is varying, my flux always varying. So torque is directly proportional to the pi into IA. From this equation only, I can draw the characteristics of the speed, torque and then armature current and all. This is a very important formula. Please note it down. This is the torque equation of the DC motor. Yes? Any doubt? I have said twice.
Yes, the three are very important. What the ma'am solves in today's class. It is the basic equation, torque equation, and then the voltage equation. All are very important. But it is used to solve the problems in both the module 2 and module 3. So please make note of it. If you're having any doubt, kindly unmute and ask. Okay? Or else you are chat in the chat box. If you're having any doubt or any questions, any queries, please unmute and ask. If you're having any doubt, till now it's clear. Please respond.
Somebody unmute and say.
303 Aravind. 303 Aravind. Are you able to follow?
Yes, sir.
Yes. Okay, thank you. The next, I'm moving with the types of DC motor. I'm going to erase. Please copy.
No, Vidya ma'am.
Yes, sir.
They are request to write larger, ma'am, because some words are not clear. They are telling like
Okay,
that.
sir. Okay. Is it visible or shall I rewrite the equation once again?
Guys, it's visible only, no? First, want to write it back. The important equations.
Have you all noted down? Is it visible? T is directly proportional to pi IA. Or shall I rewrite the equation once again? No one is responding.
Please rewrite the last ones once again.
Yes, sir. Yes, sir. The last equation is
No,
equal
better.
to 1 divided by 2 pi IA P Z by A. This is the final equation. Again, from this I can write it as torque is directly proportional to pi IA. This is the final equation. From this equation only, I can draw the characteristics of the DC motor. This is the last step. The next one is types of DC motor.
Can anybody tell what is the types of DC motor? It's already, I think we are taking this topic more than 2 times.
Please copy this. So normally the DC motor is classified into separately excited DC motor and self-excited DC motor. The self-excited DC motor is further classified into DC shunt motor and then DC series motor and compound motor. The compound motor is further classified into long shunt DC motor, short shunt DC motor and compound motor and differential DC motor. So this is the classification of DC motor. First copy it and then I will explain one by one. This is the classification of DC motors. I have to draw larger. Is it visible? I have to
No, but,
see the
But we can draw larger, ma'am.
larger, sir. Sorry, sir. Is it okay now?
Yes, ma'am.
Is it okay? All of you able to see?
Yes,
Yes, ma'am. Able to see, ma'am.
Okay, ma'am.
Ma'am, letters மட்டும் கொஞ்சம் big size ல எழுதுங்க, ma'am.
புரியல.
Ma'am, they
Letters
are request to like letter big size.
Letters பெருசா எழுதுறதா? Okay. Now is it okay? I kept again. This is my separately excited DC motor. This is F. What is F? What is F?
Anybody tell what is meant by F?
What is F?
Gauri Manoj.
F?
Field.
Yes. F is nothing but field winding. A. What is A?
Prasanna.
Armature.
Armature. So every time I have to draw the armature with respect to motors. I cannot draw the field same as armature. Field varna mari armature eppovume na vadey maten because armature is center part, cannot see it. So every time I have to draw with respect to motor M, then only I can write that A1 and A2, which means it is inside the armature winding. So the armature in all the textbooks, they have followed the same pattern. While drawing the armature, they all draw the motor and then name it as A1 and A2. Nothing but armature winding. There is nothing but armature. Then The field I can draw like this, F1 and F2. It's a field winding. What is separately excited motor means? I can excite it separately. The field can be excited separately and then armature can be excited separately. As I said in the construction part, if the both winding is separated separately or field, I can give supply to field as well as armature. That is called separately excited DC motor. Is it clear? Is it clear? I'm giving separate supply to both field and armature. That is called separately excited DC motor, nothing else. Is it clear or not? Have you all able to follow my words? Say yes or no?
Yes, ma'am. Proceed.
Yes, this is the separately excited DC motor. The next one, I'm moving with the self-excited DC motor. Self-excited DC motor is nothing but the same diagram. I can going to redraw. Have you all copied the diagram? Have you all copied the diagram? Yes? Say yes or no?
No, better, ma'am. No, Vidya, ma'am. Don't rub it, ma'am.
Okay.
We shall draw for the self-excited. We will compare it both.
Then only you can understand, I think. Is it clear now? From this easily you can say what is mean by this is it visible? It is my self-excited DC motor. The before case, I'm giving a separate supply to both field and armature. That is called separately excited motor. But here, I'm giving supply for common to both field and armature. With the help of the field, the armature gets supply. So that is called self-excited DC motor. Is it clear? Is it clear or not? By seeing the diagram, you can easily understand separately and self-excited. Separately, I have connected field alone and then armature alone. I have giving separate supply to field as well as armature. So that's why it's called separately excited DC motor. Coming to the self-excited motor, I have connected together. I have given the common supply. With the help of the field, armature gets supply. That is called self-excitation DC motor. Is it clear or not? Somebody unmute and say, have you all understood separately and self-excited?
No, they are replying in the chat box. Yes, ma'am.
Okay, sir.
Yes, ma'am.
Okay, and then next, the self is further classified into shunt motor, series motor, and compound motor. I'm going to read the shunt motor. Already teach more than third time, I think so. If my field winding and armature winding is connected in parallel, that is called shunt motor. இப்போ ஒன்று வரைஞ்சதுல self excited வரைஞ்ச அதே இதுதான் இங்கே வரைகிறேன். That is called shunt motor. This is my A1, this is my A2, this is F1, this is my F2, and this is my supply, DC supply, and then this is my IF, and then this is my IA, sorry, IL, then this is my IF. The same diagram, the last I have drawn the self-excited is nothing but shunt motor. If my field winding and armature winding is connected in parallel, I used to say is a shunt motor. You cannot see while looking any motor, but in their nameplate they have given shunt motor or series motor, which means you have to know it is connected in parallel. So I'm going to write the equation for the shunt motor. Here my IA is equal to IA plus ISH. I will say how I'm getting this equation. Listen. Yeah, I can say field as shunt winding also. Please note it down. If some books they have given a field as shunt. So here I have connected in the parallel manner. I can say the current flowing through the field is shunt. So ISH. So my IA load current will always follow the IA plus ISH. So the current will be divided into IS into IA. So my total current will be, the load current is equal to IA plus ISH. This is very important. By solving a problem, you have to use this formula. Once, if you all understand the equation, while moving to the problem, you can easily know why I am saying the IL here. Because in shunt motor, the load current is always the combination of IA plus ISH. IA is nothing but armature current, and then IS is nothing but field current or shunt current. Here it is shunt motor. The field winding, I used to say it is shunt winding also, nothing but ISH. And then another thing, I can derive the equation V is equal to I into R. Here it is connected with respect to ISH. So I can get from, I can write it as VSH and ISH. So I can ISH is equal to V by R. The same formula, V is equal to IR. The Ohm's law, with the help of this I can find out IS is equal to V by RSH, because in some cases, in some problems, they won't give them the shunt current, but they have given the shunt resistance and then voltage. From this, you can find out the ISH value. So this is another formula you have to know. And then finally, you already know that V is equal to EB plus IARA. This is a common voltage equation after DC motor. Yes, this is the thing you have to know. Please write neatly. You have to use from the next class. From next class, I have moved with the problem. So please note it down. Any doubt in it? Any doubt in shunt motor? The same simple formula. In case of power is equal to V into I, then V is equal to IAR. The same formula only we are using in the all the module 2 only. Module 2 we won't go with another formula. So basic formula you should know, the Ohm's law and then power formula. V is equal to V into I, and then V is equal to I into R. And then the common voltage equation are the things are same. I have taught in the first itself the torque equation and then voltage equation. From this only I can go with the characteristics equation of the shunt and series motor. Have you all understood? Is it okay? Is it okay? Shall I move to the series motor?
Yes, please respond.
Shall I move to the series motor? Yes. Series motor, what will happen? If by connecting the shunt winding or field winding and then armature winding in series, that is called series motor. My series motor diagram. In some books they have given S1 and then S2 and then A1 and then A2. This is my series motor. Here
Ma'am, erase the shunt motor heading.
Yes, sir, I have erased that.
Ma'am, it is noted as shunt motor. Ma'am.
Sorry. So here the same current is flowing to the both series and then armature winding. So I can easily write it as IA is equal to IA. Yes? Am I correct? In before condition, the current is flowing field as well as armature. So the IA is equal to IA plus ISH. But here the same current will be flow from series as well as armature winding. So I can easily write it as IA is equal to IL is equal to IA. Yes? And then you can write it as ISC also. Nothing but ISC. In some cases, if it is series motor, the winding will be series, so I can write it as ISC. The last case, it is shunt winding, so it will be written as ISH. So it depends upon the shunt and series, the notation will be changed. So IL equal to IA equal to ISC. All the current will be flowing the same direction. The same current will be followed to the armature also. From this, I can write it as IA is equal to IL is equal to IA. Is it clear? So the next one, I can write it as V is equal to EB plus IA into RA plus IA into RSC because here the resistance value will be varying the current because it is connected in series. In parallel, the voltage will be same. That's why I didn't took any value in the field. But it is connected in series. You have to took the voltage value also. Voltage is nothing but V into IR. So I have took for the shunt and series winding. The last case, I'm repeating once again. Before that, you have to know if it is connected in parallel, the voltage are same. Voltage value will be same. If it is connected in series, current value are same. Current value same. Here the voltage same, it is current same. So that's why in last case, I didn't took the value V is equal to EB plus IA RA only I have took because the field and the armature is connected in parallel, the voltage will be same. There is no effect on voltage. So that's why I have took the value in shunt is equal to V is equal to EB plus IA RA. But in this case, here it is connected in series. In series condition, voltage will be differing. So I have took for the series winding and then armature winding voltage equation. Voltage is nothing but V is equal to I into R. So EB plus IA into RA plus IA into RSC. You can write it as ISC2 because here it is a series winding. So ISC into RSC. We know that ISC is equal to IA. So I can write it as ISC instead of IA. So the next condition, EB is equal to, I can take it as IA is common, IA into RA plus RSC. This is the voltage equation of series motor. Yes? Yes? Any doubt?
Yes, ma'am. Guys, we're having any doubt?
Is it clear? Is it clear or not? Somebody unmute and
Guys,
say.
anybody unmute and answer the question. If you're having any doubts regarding the shunt and series motor or else the basic equations, you will discuss here. Vidya ma'am,
Yes, sir.
we will take compound next class, ma'am, because we are having only 5 minutes more.
5 minutes more. Okay, sir. Every
We will
time I have
discuss.
stopped only the series motor. I thought to the compound motor also.
Okay. Because we are having compound, we are having different types now, ma'am. So we will discuss next class.
Okay, sir.
Guys, we are having any doubts regarding
Any
this?
doubt in it? Tomorrow I have to see Longshan and Charchan and compound and then characteristics. Tomorrow evening class.
Post you the assignment question for the module 1 that is posted here. So the form
You
will
have to submit the assignment only with Google Classroom. Then only we have to take this consider, and then we won't consider that. So you have to join the classroom. I'm repeating once again. We have to submit your assignments into the classroom only. Then only we have to consider. Otherwise, we won't consider.
So today, I have given you the link for the today's assignment number 1. So till now, you are having any doubt regarding the types of motor or what is a DC motor, separately excited, what is meant by separately excited, what is meant by self-excited, or different types of shunt series compound motor like that? You are having any doubt? Please unmute and ask. Hello, guys. Yes, you are having any doubt regarding the DC motors? 104, Ajit.
Sir, it's time 12:39. I can teach compound motor also. Still 5 more minutes.
அப்படியா சரி
Yeah, till 40. No,
அது
Isma.
இருக்குது
If you're having any doubt regarding this,
சந்துக்குள்ள வரீங்களா இல்ல மெயின் ரோடா சரி வாங்க ம்
Any doubt?
so
Any doubt?
having any doubt?
41 minutes. So others, you can write the MCQ.
No, it's not MCQ. It's a assignment question. They want to upload it back to us now.
Okay.
So use PDF or image file to upload the question. So it is a heating and cooling curve derivation. So we want to derive the equation and send us back to us. Okay. We want to submit it with the image file or PDF file. So by tomorrow we will close the form. So before tomorrow, we want to submit it back to us. Okay. By tomorrow class.